Okay, real quick, just let me get a feel for the audience. I know we're at a JS event, so my first question should be obvious. How many of you are JavaScript developers? Like you would identify yourself as a JavaScript developer. Okay, so, but usually JavaScript is a secondary language for a lot of people, so I'm just curious, .NET developers? Some? Java? Python? Ruby? Anybody in the room morally opposed to hand raising? That's, all right. Oh, I like Utah. Usually I get one, but I got like a whole room full of people. Okay, so this talk is the Skeptics Guide to Functional Style Programming. There's at least one other functional JavaScript talk here that might give you a slightly different perspective. But if you've been doing JavaScript for any period of time, you've probably heard this term, especially in the open source community, in kind of the elite community. Everybody wants to do functional style. But I have a Pluralsight course out there that literally is the Gang of Four design patterns for JavaScript. Like I'm an OO guy. I was a Java developer. I was a .NET developer. I started doing JavaScript. And so I'm real in the nuts and bolts of the object stuff. But you can't be in JavaScript and not be talking about functional. So every time I talk to somebody about functional style JavaScript, I hear this phrase. Have you heard this phrase before? In JavaScript, functions are first-class objects. That makes it functional. And my response is always yes. Functions are first-class objects. It's right there in the phrase that they just used. But got to go along with it. So I spent some time researching this functional programming thing. Still a skeptic. I'm still not all like gung-ho on it. But I did what any normal American person would do when they don't know what something is. I went to Wikipedia. Right? And I just walked through the Wikipedia explanation of what functional programming is. And it helped, actually, quite a bit. So, in computer science, functional programming is a programming paradigm. We'll just get that out of the way right now. It's just a way to write programs. So that's easy. And this one is important. We'll come back to this one quite a bit. A style of building the structure and elements of computer programs that treat computations as the evaluation of mathematical functions. Right? So, just a little insight on me as a person. I went to college as a math major. After my freshman year, I took Cal 1, Cal 2, and Cal 3. We did quarters. My sophomore year, I was a computer science major because I was done with math, right? But then my daughter came home from school one day, and she had homework, and she asked me to help with her homework, and I love to help her with her homework because it's not Cal 3, right? It's algebra. And I still feel like I can kind of do that. And she had this stuff. How many of you have seen this in math before? So it's in algebra, right. So f of x equals x plus 2. And I got very excited when I saw it, and she was not amused because I was like, functions, I do this every day. This is literally my life. And her response is, yeah, Dad, I know, but this is math, not computers, so, but I helped her anyway. But everybody knows how this stuff works, right? You pass in a value for x, and the result is x plus 2, right? So f of 3 is 3 plus 2 equals 5. When functional style programming says it makes use of mathematical style functions, this is kind of what it's talking about, right? We're going to write a small little function, and we're going to pass something into it, and we're going to get the same result back out of it. That's kind of what they're talking about. And then you get this gem. It avoids changing state and mutable data. I don't know how long you guys have been doing JavaScript, but nothing is immutable in JavaScript. Literally anything you want to change can be changed, period, no exceptions. And so this is kind of, in my opinion, where the whole conversation falls apart. Which is why this talk is called A Skeptic's Guide to Functional Style JavaScript. Right? Because there's going to be some things in this whole conversation that we just don't do in JavaScript very well, or it's not enforced. But we're going to kind of go with the style and see where that gets us. This is my my best example of what our mindset's going to be as we talk about this. So, Martin Odorsky says the programmers in that segment, talking about functional programming, now remember, he's a Scala guy. He's a real functional programmer. Not a JavaScript functional programmer, but like a real functional programmer. So the programmers in that segment like functional programming because it makes code clearer, better structured, and it prevents many cases of errors. When we start talking about functional style JavaScript, I'm focusing on these two things. We want clear code, and we want better structured code. That's ultimately what we're going to get down to. How many of you have heard this phrase? I go out to lunch on a regular basis with a guy who is a hardcore functional style JavaScript guy. They now do Elm, which I give him more credibility because he's now doing like real functional programming. But he would say this phrase, pure functions are awesome. He actually uttered the words to me one day. When I can write a function, and I can tweak it and I can refactor it to get it to be a pure function, that's just the best feeling. Like, why? That doesn't even make sense. And I would ask him, he's like, what do you get out of a pure function? He's like, well, it's pure. I mean, the name implies it's a good thing, right? Side effects are evil. This is the other big functional thing. Like, functions that have side effects are just horrible. One, they're not pure. But two, there's all this other random stuff going on. And my response to that typically is, yes, that other random stuff is like the work that needs to get done. Right? I need to call APIs. I need to change values. I need to do all this stuff. Those are side effects. That's the whole point. But a lot of times, okay, so XKCD, if any of you don't know. So why do you like functional programming so much? Tail recursion is its own reward. This is usually what I get from functional style people. Because they don't really understand. It's a buzzword. It's something they do. They get really excited about it. So, hey, I like it. And tail recursion is hard. Right? This is not, yeah. Okay. But ultimately what that comes down to is this. I want you to walk away. You're going to walk away with two things in your brain at the end of this. This is the first one I want you to walk away with. The programmers in that segment, functional programmers, code that's clearer, better structured, remember I said those two, and it prevents many classes of errors. In functional programming, see, mine does it too. Oh, because it's tight. Okay, hold on. We'll see if that works. In functional programming, there are tools. There's a compiler. And if you have side effects, and you have unpure functions, and you have all of these things, the tooling actually will catch it and will fix it. JavaScript has no such thing, right? So if you have side effects, so any React developers in the room? Right, so state. What does React say about state? State should be, not quite. State should be treated as immutable. Because in JavaScript, it's not immutable, right? You can change, and people change state all the time. They just don't even realize they're doing it, and that's part of the problem. Because they don't understand necessarily how things work. So I spent a long time, years, basically making fun of all the functional people, because that's what I do. And then I met a guy named Nate Taylor. So Nate Taylor's a good buddy of mine. He's from Iowa. He's also a Pluralsight author. And this is his @ if you want to tweet at him and say, thanks, Nate, for teaching John about functional programming. But he's an Elixir guy. And he started doing some functional style JavaScript. And he sat down, and he was the opposite of every functional programmer I have ever met. And he explained it this way. So the bit flipped for me on this, and I actually became fairly pro-functional when you think about it this way. You can never avoid side effects, right? At some point, you have to get work done. Okay. Not all of our functions are going to be pure, and not everything's going to be immutable. So right off the bat, so when I talk about functional programming, those are my 3 rules. We're not going to avoid side effects all the time. We're going to try, but we can't always avoid them. Not everything's going to be a pure function, because at some point, we got to do something. Right. Sorry, that's just life. And not everything has to be immutable. At some point, I need to change some data, right? So that's, those are my 3 rules. This is the second thing I want you to walk away with. And I'm going to spend the rest of the talk basically underscoring this. Functional style programming is about using less brain power, not more brain power. Because a lot of times you think functional style programming, it gets complicated. And we're going to talk about monads here in just a little bit. And that's complicated. Functional style programming is about using less brain power and trying to make things simpler and pulling everything apart so that we can understand what's going on. It's about small, composable things. Back to the definition, the Wikipedia, which is I'm using as my stake in the sand. This is what functional programming is. It's a style of building the structure and the elements of computer programs. We're going to talk about building small stuff. A lot of OO people and a lot of systems people, so if you're a systems thinker kind of person, we think like this, right? I think about systems. I think about the whole thing. So we've got some APIs over here. We've got Dallas down here, which might be our database. And then, out here it gets kind of dark, but we've got some bright points here and there. Anybody know what that is? It's not a town. So that's oil fields in North Dakota. We spent a day trying to figure out what in the world that city was that was up there. But this is how I approach programming 9 times out of 10. I would think about the big picture. Where does everything go? How does everything lay out? Functional style, when we start talking about functional style, we're talking about the streetlight. So instead of the big picture, I want to talk about the very small, little, minute thing and focus all my energy and attention on this until it's right. And then I can move on to the next thing. Because eventually, you get enough of this stuff, and you get that, right? You've got to have both sides of this conversation. You can't just have one or the other. All right, so that's enough talking. Let's look at some code. So, arrays. How many of you, over the course of your career, even once, have iterated over an array? Right? Today, have you done it today? Well, you've been here. So right? This is literally most of what we do in our careers is we get an array, we iterate over the array, we do something with the data, right? We're either looking for something or we're doing something with it. So functional style arrays are the best place to kind of start getting this mindset of how to do it. So let's look at a for loop. So this is a for loop. Somebody tell me what this for loop is doing. Right, so you read the comment, which is great. See, because I commented it just so everybody would know exactly what was going on. So we're going to add 1 to each item. So we're basically doing, and there's other ways you can do for loops. There's the for of and the for in and all these other different ways to do it. But so we're iterating over the list, and we're adding 1. So when I write this out, what's gonna be printed? You were so close, but not close at all. What's going to be printed out? Oh, wait, who said it? 2 through 6, just like that. 2, 3, 4, 5, 6. Right, that's it. So I got to go with an easy example so that as I start talking about this, we go. Okay, now remember I said streetlights, right? We want one thing. We want to talk about one thing at one time. The problem with this example is we're actually talking about 2 things. We've got our iteration code. So we have written some code that's going to iterate over lists, right? All agree with that? And we had to write code to do that. And it's not always this straightforward. Sometimes we do some other things with it. We also have our worker code. So the worker code is what actually is going to do the job, right? And what we now have, and in more complicated code, we have these 2 things that are all kind of entwined in each other because we've got to understand I and what I references and all of this kind of stuff. And yes, we do this a lot, but it can get complicated. So let's break this up a little bit. How many of you have used list.map? You're already functional style programmers. Right there. Yay! Okay. So, right, list.map. What does list.map do? Who raised your hand? What does list.map do? Right, so list.map iterates over an array. And it applies a function to every. What does this do? It iterates over an array and applies some code. Right, it's the same thing. But it's one line of code and I don't have to worry about anything. I just do list.map, right? It makes it significantly simpler and easier to do. So there's your iteration code, now is list.map. But what are we doing? What were we doing to each item? This was a simple example. What were we doing? Adding one. Great crowd. Good job. Okay. Right. So we're adding one to everything. So I now need to pass a function into list.map. Now we get to talk about pure functions. I'm going to use a pure function in this situation to work with this. Okay. So what is a pure function? A pure function, in computer programming, a function may be considered a pure function. These are like the beautiful functions. If both of the following statements hold true, you got to have both. When we talk about something later, you only have to have one. In this case, you have to have one. A pure function always evaluates to the same result given the same argument. Always. No exceptions. That's this, right? If you pass 3 in, you're always going to get 5. Period, no exceptions, right? So a pure function says, I'm going to pass in a value, you get a result. The example here, function add A and B is pure. Math.random, not pure. Because math.random, you never know what it's going to hand back, right? The other example is, it's going to, evaluation of the result does not cause any side effect. Side effects are evil, right? So, which is funny to me. Anyway, so no side effect or output such as mutation of mutable objects or output to I/O devices. Right there. That's why I said not everything's going to be pure. At some point you need to write something somewhere, right? But no side effects. Let sum equal 0. If we add to sum, this is a side effect, right? So I'm impacting something outside the scope of the function. Therefore, it's a side effect. It doesn't work. So my question to you is, why pure functions? Why would we ever write pure functions? A couple of reasons. Who said that? That's testable. That is actually very true. It's not one of my examples, but good job. So the first one, that's better than what I was going to say. So we're going to go with what he said. The first box here is going to say they're testable. Okay, not really. The first one's going to say it's less to keep track of, right? So in a pure function, it always operates the same way. I never have to wrap my brain back around what's happening here. Because the function says add 1, I'm adding 1, I don't have to worry about it, right? And yes, I can write a test for that, but that's a silly example. There are more complicated ones that are much easier to test, yes. The second one, less brain power, because this is the idea. If I have less to wrap my brain around, if I don't have to worry about side effects start to incorporate more brain power, right? Have you ever, you've heard the thing, never interrupt a developer when they're working, because they've spent 30 minutes trying to figure out how everything fits together, and then you walk over and that whole thing collapses, right? This is part of why. Because you've got to keep track of all of the things that are impacted by what you're doing. If you minimize the things that are impacted, it's less work to get back in and get back to doing what you're doing. It's also not a rule, always. So that both things I'm going to show you, it's not a rule, it's the same on both times. Okay, so think about this. So we're going to add in a function, and we're just going to say function item, return item plus 1. Item, where does item come from? Map. Map's going to hand in the item, and each item, and we're just going to return back item plus 1. Arrow functions. How many of you use arrow functions? Yes. So this looks much better. Item, return item plus 1. If you work at my company, the guy who does my code reviews is painful. And he'll kick that back. He'll say, no. Write it like that. You got very excited. Almost a little too much, actually. Right, but so now I've got this, right? So list.map, item plus 1. This looks great. compared to that big gross for loop that I had, does this make sense, right? Are we still doing the same thing? Add one to each item. Yep, same thing. Don't go, no, shh, I'll get there. Hold on, don't spoil, no spoilers. Okay, no anonymous functions though. I don't like anonymous functions. I think they're gross. I would rather just define it up here and it's list.map add one. This is clear. Everybody understands exactly what's going on all the time. You don't have to worry about it, right? Yes, it's a simplistic example, but this is a perfect example of a functional style. I broke everything apart. Now I've composed them back together. There we go. Same task, one line of code, well, 3 lines of code, but whatever. So it was this, now it's this. What's it going to print out? Now's your big moment. 1, 2, 3, what? No, but we're adding 1. Okay, right. It's going to print out 1, 2, 3, 4, 5. Because remember, we're functional style now, right? We're not OO. We're not doing the for loop stuff. We're functional style. And what was the last rule of functional? Avoids changing state and mutable data. We don't want to change the thing we're operating on. We're going to create something new and pass that back. So what you end up with here is you just get a new list. New list equals list.map, and then you've got a new list. And this freaks some people out. Because what happened to lists? Right? I wanted lists, and now I've got this new list thing, and that's gross. And now I've got 2 arrays, and people will start to argue over performance and memory management and all this stuff, and I basically just calm down. It's not that bad. But let's talk about immutability for a second. Why do we do immutability? Is it? Okay. So the first thing, one thing immutability does, in my skeptical view, right? I'm not talking about like the ivory tower functional program. I'm talking about me as a skeptic of the whole thing. Here's what I like about immutability. First things first, it enforces options. And I'll explain that here in just a second. I am guaranteed to have several options about how I want to work with this thing. It's easier to validate. So this is why state is considered to be immutable. Because if I change something in an object, that object is now different, but it's the same value. The pointer is the same. If I create a new one, then I can just check to see if they're the same thing and when they're not. So this is how state works, right? Less brain power. It's easier to reason about and easier to think about if you don't have to worry about, hey, list changed. I called list.map to add 1, and now list is a different thing. I don't have to worry about that. Now, when I say it enforces options, here's what I mean. So list.map, what if I don't want list to change? So if list.map changed list out from underneath me, and I didn't want it to change, I would have to make a copy of it up above. And you can't just do equals, because that's still the same thing, and so it would still change the whole thing, right? So I have to actually do a full-blown copy, and then I run map and all of this stuff, and I don't want to do any of that. I want my original list, so I can do this. What if I want list to change? How complicated is that? Yeah, I just do that, right? This is easy. So having these functions be immutable means that I get to decide how I want to deal with these. If I want it to change it, I just add list. If I don't want it to change it, I change it to a different variable. All right, so what about more complicated loops? Because not everything is just apply a function, right? Well, guess what? There's a whole suite of these functions, and some of them are pretty cool. All right, so we've got list.filter. Same thing, is even. What does this do? Without even looking, I've put the answer up. I don't know why I did that. Okay. Ignore that, right? What is this function doing, right? You can just look at it and tell me what it's doing. I'm filtering out the odd numbers. So, right. I'm only taking the even numbers. And you can tell that because, look, list.filter is even. Self-explanatory. I didn't need to put a comment up there because you can just read the code and see, hey, yeah, that's exactly what it's doing. So basically what filter does is it just takes this function, which is not 0, becomes 1, and it's even. So that's filter. What if I wanted to find something? Loop over an array and find something. See, if you liked my arrow functions before, you might like this one. This one gets gross. I'll explain this later. I talk about it here in just a little bit. But, so what's happening here? So I've got a list of names, list.find, get one, Rachel. I'm finding Rachel. That's all I'm doing, right? Just looping over and applying this function right here, which is gross. I'll give you that. Okay, what does this do? My arrow function people back there. What's happening here? So the first function call, I pass in the search criteria, which is Rachel. That returns this function, right? And then I apply it. Yep. Closures are awesome, but that's not this talk. Okay. Oh, right. But how often do you want to find, like, I'm looking for something and I get the thing, and that doesn't work, right? I don't care. I want the index. There's a find index as well, which makes this super nice. Okay, so and that gets you 2. Not everything is always self-contained. So let's talk about this. This is the last one of these we're going to talk about. Sum equals 0. I'm just adding them all together, right? Or you're running calculations against things. So there is a reduce. List.reduce, and I pass in the sum, and it's going to pass me a sum and then the item, and I just kind of add them all up. And that's not right at all. My slide's wrong. But you guys know, what's the it's going to be 5, 9, 10, 12, 13, 15. 15 is the answer. All right, here's where we get to start having some fun. If we haven't been having fun up till now we get to have some fun. Let's add one and then sum them. Because I'm not changing things out from underneath myself, because I'm returning new arrays, I can chain things. And I can do this. List.map add 1.reduce sum list 0. 0 is just my starting point. There, I do it all in one line. Now does this sound like less brain power? Not really, if you're trying to wrap your, but once you get it, once you start thinking in this way, this is significantly simpler than the code that we would have had before in our big for loop and all of the gross stuff. And it equals 20. This slide is correct. But ultimately, this is where all the work went. Currying. How many of you have heard this phrase before? Currying. Currying is this really cool, weird, interesting thing. So let's say we have a function called add that takes 2 parameters. And what currying allows us to do is, in mathematics, currying is the technique of translating the evaluation of a function that takes multiple arguments, this, into a sequence of functions, each with a single argument. That. Currying. It doesn't even make any sense. Like, why in the world would this ever need to happen? And I'm not a huge fan of currying in most cases because I feel like it just makes things more complicated. But there are some cases where when you start to think of things this way, it becomes actually fairly interesting. I'll give you an example. I have a list of buttons. 1, 2, and 3. When I click on the button, I want to display a message. How would you do this normally, right? So you have to set up a click handler, and then you've got to go, so you either have to have a click handler on each button, or I just want one click handler, so I do this dot on click. The name is the name of the item, and then I have to loop over my buttons every time something's clicked to get the message. Has anybody ever written something like this? It may not be buttons, but a lot of times it's a drop down or something like that. Right. It would be so much better if my onClick came equipped with my index. Right? What if I could pass the index into my onClick event? Then I don't have to loop over the buttons anymore. Now I just can go get it. Is this the way on-click handlers are called? No, you just get the event, right? We've seen this before, just a minute ago. It looked like this, right? And we went to this. What if I could do the same thing with my click handler, right? What if I could instead pass index in and split that apart? Okay, so let's talk about higher order functions for a second, and then we'll come back and finish that thought. So a higher order function, this is simple. There's a wall of text here. I'm not even going to read it. Basically, a higher order function does at least one of these two things. The one thing that it does is it takes one function as an argument. One or more. So if you have a function that takes a function as an argument, that's a higher order function. Promise, anybody have a promise? Promise.then takes a function, right? That's a higher order function. Anything with a callback, higher order function, right? Or it returns a function. So anything that takes a function or returns a function is a higher order function. That's all it is. That's all it is. This was an example of a higher order function. So get1 took a string as a function, but it returned what? Get1 returned a function. Therefore, it was a higher order function, right? That's how that works. So what if I did this? Get on click returns index. Get on click with index is going to return my event handler. Now I call get on click. This.get on click, pass in index, and now I have event handlers all wired up that just do it. So this is a somewhat example of currying. It's just we pull it apart. We think about functions as things instead of just pieces of code. So this function is a thing. I'm going to pass it back, and I'm going to wire it all up. This is much, much simpler. Oh my goodness. How many of you have heard the term monad before? How many of you understand what a monad is? I got one. I got one. Okay. I did not imply that at all. Just so we're clear, I totally believe that you understand monads. But here's the problem with monads. Once you understand monads, you can no longer explain monads to someone who does not understand monads. This is a real thing. You can go look it up. Like, I didn't make this up. It's longer if you Wikipedia. It'll be a longer explanation. But this is kind of the idea, because monads are weird. They're just weird. But here's a little bit of an explanation, as to what monads are. So in functional programming, a monad is a design pattern. Let's stop right there. It's just a design pattern. Just like any other design pattern that's out there, a monad is just a design pattern that defines how functions, inputs and outputs can be used together. Stop right there. What do we have in the OO world? And I know it's not the same thing, don't worry. What do we have in the OO world that's inputs, outputs, functions, types, all kind of mixed together? Right. Yes. An object or a class or whatever you want to call it. Right. But it's not that. It's a monad. So don't confuse the two, even though you're welcome to confuse the two. It's fine. They can be used together to build generic types with the following organization. 1, you define a data type, and then you create functions to edit that data type. And there's a reason why we have monads in functional programming. One of the rules of functional programming is no mutation of data and no side effects. But we all know that at some point you have to change data and you have to have side effects, because otherwise you're not getting anything done. So in a true functional language, a monad is a thing, and again, you're going to have to go play with it yourself if you really care. A monad is a thing that enables that stuff to happen. So if you're writing Haskell, you need to change data, we're going to use a monad. A monad basically just are things that get around the no side effect rule. That's ultimately what it comes down to. And if you are a functional person and you really understand what a monad is, you are going to be very irritated by this simple explanation. But ultimately, that's what it comes down to. And I'm going to show you my point. I'll prove my point. I'm going to do a very simplistic monad. This is a real monad. If you go Google monads, you'll come to this example often. And this is what a monad is. And it's a lot of text. But I'm going to kind of talk you through what it all looks like. So, up at the top, we have an identity. And so this is the identity monad, right? So we have a thing called an identity, and we have a thing called value inside the identity, right? So the monad has a thing called value. And it's using the this keyword, don't freak out. But this dot value basically means inside my thing, when I do a new identity of 5, my value is now 5, right? Now I need to change that value to something else. So what a monad has is this thing called bind. And what this thing called bind does is it applies a function to my value. That's all it does. So I'm calling x.bind, so my identity, and I'm changing my value by adding 2. So I'm creating a new monad, because we can't mutate. We have to create a new copy of it with a value plus 2. And now I get a new monad. And that's 7. Thank you for this. Right. Remember what I said about math? Like I quit being a math major? Because simple addition is apparently very difficult for me. I think at one point I was adding 3, but no excuses. I'm not going to make an excuse for myself. This is a monad. This is ultimately what it comes down to. And this is why you see a similarity between an object, right? So I've got a thing that's holding my value, and I've got a series of functions that can interact with that value. One example of a monad is think about a promise, which is a weird if you kind of have to tilt your head sideways a little bit. But you have a promise, which is a thing. And you interact with that thing by passing functions into the .then, right? So the .then is essentially the .bind. You pass functions into .then, and it's going to give you data back. And you can manipulate the things that are inside that promise. That's ultimately what a monad is. Am I close? Like, does that ish? Okay, we'll go with that. I appreciate you disagreeing with me and not admitting it out loud. Okay. Right, no, but that's, so here's the beauty of monads in JavaScript. We don't need them. So I'm just going to leave it right there, right? Because I don't have to worry about side effects. I can do side effects if I want to, so I don't have to have this big thing. Now, we still have them. Like I said, a promise is an implementation of a monad. So we still have them. But don't, like, freak out about it, right? Because if you need to change something, just go change it. Like, don't worry. Because ultimately, it comes down to this thing, right? I'm going to come back to this thought. We want to make code cleaner, clearer, and better structured. But when you go to the hardcore functional guys, every time I sit down and have lunch with these people, and I do it often because I like opposing points of view and I like to talk about it. I'm glad I did because I've learned a lot. I talked to a couple of really hardcore Scala guys. And they kind of made fun of the functional JavaScript stuff. And of course they did, right? I mean, they're Scala guys. But the reason why they did is because it's all make-believe and pretend, right? Because it's the tooling that does all the work. It's the tooling that enforces no side effects. It's the tooling that enforces no mutation of data. It's all of that stuff. JavaScript doesn't have any of that, so we're just going through the motions if we don't have the tools wrapped around it. Now, there are some tools that JavaScript, so Immutable.js helps quite a bit. So if you want something to be immutable, go with that. Sealing an object does not get you all the way there. But despite that fact, despite the fact that it's all still, make-believe and pretend, and we're just trying to mess around with this stuff, for us, for JavaScript developers, we adapt a mindset, right? And the mindset is, I'm going to simplify everything I can. If I'm writing a wall of code to try and do something, I'm going to try and start pulling all that stuff apart. I'm going to write little functions here and there that are going to do things for me so I don't have to understand what a wall of code looks like. If I get, so the talk right before this, who was in the talk right before this? Right, she put up some metrics like lines of code, less than 20 lines of code in a class and all. If I get higher than some of those things, the brain power involved is too much. I want to pull all that stuff apart. And that ultimately is where functional programming, functional style comes in handy for us. It simplifies the pieces and it keeps the interactions as simple as possible so that I don't have to worry about it. Right, so ultimately that's what you need to walk away from. I've got a few minutes for questions. So throw them at me. It's fine. What you got? Questions?
If you go back to the old paradigms of object-oriented programming, saying, okay, I don't want any methods more than 20
Yep.
It's the same sort of mindset.
Keep it simple. Absolutely. The reason why functional style gets a little bit different is because we have tools that we didn't have over in the old OO. The new .NET's got some of it, right? But because functions are first-class objects, because I can pass these functions around, and because I can play with them a little bit, the tooling that I have inside JavaScript is much more bent towards letting me do this stuff. And it makes it a lot easier.
I think also the idea that the basic function being provable, so it's just useless to write a unit test against it because it's provable. You don't have to write a unit test. It's always going to work the same way. That's a big advantage of it.
It is a big advantage, and in many cases, that is absolutely the case. So the statement being, since my functions are so simplistic, especially the ones I threw up here, like the function that I threw up here was, item plus 1, right? That's just always going to be. And so it makes it much more simple, and you don't necessarily have to really get 98% test coverage against all of these functions that you have. The advantage is, in the real world, a lot of times these functions do become a little bit more complicated. Not a lot, though. If they become a lot more complicated, you're not necessarily doing it right. But they will become a little more complicated, and that's where throwing a couple tests in there, but they're simple tests. If you're writing complicated tests to test pure functions, something's wrong, right? It's here's like 4 different things I can pass into this function. They all pass, I'm good. And ultimately, unit tests are not about protecting me necessarily. It's when that other guy comes along. Because my code's always right. I take that back. No, when I say that other guy, I mean me like 3 days later. You are not the same person tomorrow that you were today. And my understandings will be fundamentally different. Any other questions? Yes?
If you were to go from object-oriented programming to functional, what would you recommend, like some steps or like some way to get you there?
Okay, if I was going to go from object-oriented to functional style, and emphasis on style, the first thing I would do, and this is exactly what I showed you up here, start changing the way you interact with arrays, because that'll change your brain, right? The way you interact with arrays, if you're doing it the functional style, will immediately start to shift your focus and the way you think about things. So then the next thing you do, like my callback example, right? Now I'm thinking about functions as things that can be passed around. Oh, wait, I can do this. I can just return a function and it'll be all good, right? So that's, if you do nothing else after this talk in functional style, you should never write a for loop again. Period, full stop. Like if you find yourself writing a for loop, you're doing something wrong. You need to figure out a different way to do it using functions. All right, I believe it's lunchtime. So it's close to lunchtime. It's not quite. I'm a little early. We got about 5 minutes. But You guys go downstairs. Otherwise, since it's lunchtime, I can hang out here, right? Okay, if you got other questions, come up.